Well, hey guys, Mr. Roden here. Welcome to your Monday asynchronous lesson. And sorry we're not here, but it's asynchronous Monday. So hopefully this lesson will be a little bit of a review for you. You should have seen a lot of the stuff that I'm going to go over today in Miss Wilson's algebra class, or an algebra class if you didn't have Miss Wilson. And I just want to go over a few things about linear equations because we've been using them quite a bit in our our geometry class with writing lines of best fit and things like that. So I just wanted to practice today, so we're really strong on it when we jump back into the line of best fit next class. But before we get started, a good thing for me today is that Mr. Joyner bought us these really nice boards, and I'm really enjoying them. I can write, and I feel like it's just really working well. And I really appreciate Mr. Joyner buying these writing boards so we can teach you guys better. So anyways, that's my good thing. All right. So this is our learning target for today. I'll just say LT for learning target. And our learning target is I can write equations in slope-intercept, point slope, and standard form. And so that's what we're going to focus on today. So let's go ahead and jump into the lesson and see how we can do this. Okay, so let's take a look at slope-intercept form for a second. Now, what is slope-intercept form? Well, slope-intercept form is in the form y equals mx plus b. Y equals mx plus b. Now, why do we like slope-intercept form? Well, there's a lot of reasons. The biggest reason we like slope-intercept form is what we call a function. It's in function form. Okay, so if we wanted to, and if you remember back to your algebra, we could rewrite this as f of x equals mx plus b. So we like that because when we have it solved for y, our dependent variable, then we can write it as a function. And functions are nice. So maybe we can talk a little bit about functions more this year. But so the biggest thing is y equals mx plus b is in a function form. And it is by far the most common. It's the most common linear equation. Okay, most likely already in our class, we've talked about kind of linear equations in slope-intercept form. And so it's really, really useful. It's nice. It has good information. It provides you, just by looking at your equation, you can see your slope and you can see your y-intercept. So if I'm graphing something really quick, let me pull up a graph here. If I'm graphing something, I'll just pull up a little teeny graph here. Got my XY graph. And I have slope-intercept form, y equals 3x plus 2. Well, the nice thing is I already have good pieces of information. Why don't we call this negative 3x, so it'll stay on this graph. So the first piece of information I know is I have my y-intercept right here. So right away, I don't really have to do anything for this equation. I can see that this thing is going to cross the y-axis here. This is your y-axis. This is your x-axis. This is going to cross at 2, or 0. It's going to cross at the point 0, 2. So this is the point 0, 2 on the graph. And then this, y equals negative 3x, that's our slope. So we can make more points from that. So we can drop 3, 1, 2, 3, and then because there's a 1 underneath this, and we can draw a line. Not a very good line, but we can draw a line. So we can easily graph these things. So another big reason for slope-intercept form is it's really a nice graphing method. Okay, we can use them in our calculators. Our calculators, like our graphing calculators, our TI graphing calculators, if you have one of those, it really likes slope-intercept form. So there's a lot of reasons why slope-intercept form is so popular. But there are other forms, so let's take a look at those real quick, okay? Let me arrow down here a little bit. Now, the next form is called point-slope form, okay? And this one I don't think gets the respect that it deserves. Point-slope is actually a really cool thing. And it actually, and I'll show you why point slope is so helpful here in a minute. So point slope says this. So if you have an m, which is your slope, and then you're given an x1, y1, and that can just be any point on the graph. So if you're given a slope and a specific point on the graph, you can just automatically write it into an equation. So point slope says this. It's y minus y1 is equal to m times x minus x1. And that's our point slope form. Okay? And this is a really good, the reason I really like point slope is in higher math, as you go higher in math, in calculus, sometimes in pre-calculus, sometimes higher math really likes point slope. In fact, I've seen some math classes, the kids I tutor in calculus and pre-calculus and things in trigonometry, sometimes their teachers will have them leave it in point slope and they won't have them do that next step into slope intercept. Another reason why it's a good way to solve for it's a good method to solve for B. It actually, I kind of like it even better than just plugging in a point and solving for B. It actually works really nice solving for B, and we can talk about that. And then the last kind of equation, and this is the one that's probably the least common, okay, and this is called standard form. Standard form, okay? Now, standard form, again, is not really seen, especially at this level in math. You don't see it a lot, but standard form says ax plus by equals c. So basically, standard form is saying that you want some number times x plus some number times y equals some number. And where usually a has to be greater than or equal to 0. Usually it's actually greater than 0. Greater than or equal to 0. So this leading variable, we call it a coefficient. This leading number of the x variable needs to be greater than 0. If it's negative, then we need to manipulate the equation in order to make it positive. Usually that seems to be the way people like the standard form. Now, what is standard form good for? Well, it's really good for finding x and y intercepts. Finding x and y intercepts. Okay, it's really good for that. It's also it's the official definition of a linear equation. It's an official definition of linear equations. Official definition of linear equations. And another thing is, it's very good it's good for solving systems of equations. It's good for solving systems of equations using elimination. So if you remember back in your algebra days, you solved systems of equations using elimination. Standard form is a really good way to, if you put them into standard form, it's the A's, the X's line up, the Y's line up, and it really works out nice. And we can talk about that in this lesson a little bit. And then the last thing is when you go further in math, it's really good for these things called matrix. It's good for if you want to make a matrix out of it. And I won't really go into that too much. This is a little bit higher math. So standard form really has its place and its use also. So let's go through and let's do some examples of each form and then see if we can go in between those forms. Okay, so let's go ahead and take a look at that. Let me pause the video here for a second. Go here. Oh, that's what I wanted. Pause here. Okay, so let's say that we wanted to graph this equation right here, x plus 3y equals negative 3, but we want to graph it using the intercepts, using intercepts. Well, remember in my introduction, what form really enjoys using intercepts? Well, yeah, this is standard form. So this is a good kind of example when we want to use standard form. Okay, so how do we find the how do we graph this if we want to use standard form? Okay, so let's go ahead and do that. Well, when we're talking about intercepts, we're talking about x-intercepts and y-intercepts. So let's talk about the x-intercept. Okay, well, the x-intercept is where y equals 0, because when you're talking about the x-intercept, you're talking about where does the line cross the x-axis. Well, it crosses the x-axis when the y-axis is 0. So you're not up or down any, you're right on the y-axis here. So let me do this really quick here. Let me pause this really quick. So the x-axis is, the x-intercept is where the y-axis or the y value is 0. So if we plug a 0 in for this y value, what do we get? We get x plus 3 times 0 equals negative 3. And so we get x equals negative 3. So we know we have an x-intercept at negative 3, comma 0. And that's going to be our x-intercept right there, our x-intercept. And so we go over to, here's negative 1, negative 2, negative 3. And so there's our x-intercept right there, negative 1, negative 2, negative 3. Now, what is our y-intercept? Well, our y-intercept is when the x value equals 0. So if we want to find the y-intercept, that's where the x value equals 0. So now we're not going any right and left. We're going just, where is it going to hit this y-axis right here? Well, that means we're going to make our x value equals 0. So when we do that, we're going to get 0 plus 3y equals negative 3, which means that we're going to get 3y equals negative 3, or we get y equals negative 1. So our y-intercept is going to be the x value is 0 and the y value is negative 1. So now we're going to have a y-intercept down here at x equals 0 and y equals negative 1 right here. And then we can graph that. And so now, let me pull a line up here. When we graph that, we're going to get this kind of a line that, graph that there, we're going to get a line that does something like this. And there's our line. We graphed it using standard form. Notice we didn't talk about the slope. We talked about the y-intercept, but we didn't talk about the slope at all in this equation. Cool. And we're done. So now let's talk about another form. But before we do that, I want to give you an example. So your job, ladies and gentlemen, is I'm going to give you an equation, and your job is to graph the equation using x and y intercepts. So here's your equation. Let's do 2x minus y equals 8. So what I want you to do now is I want you to go ahead and graph this. And I want you to actually, before you graph it, I want to know what the x-intercept is. And that's going to be a point. That's going to be an x and a y point. And we know x-intercepts, by the way, it's going to be a 0 here, right, for our y value. And then I want to know the y-intercept. So that's going to be a 0 for our x value, and then you need to find that. So go ahead and do that really quick, and I'll get back with you, and we'll pull this up and see how you did. Okay, so for our x-intercept, I kind of got started here a little bit. That means our y is going to equal 0. So when we do that, we have 2x minus 0 equals 8. So we get 2x equals 8, which means x equals 4 when we divide it out, divide both sides. So we know for our x-intercept, we're going to get x4 for x, and we already knew 0 for y. All right, so now let's go ahead and do our y-intercept. Our y-intercept. Now, how do we do our y-intercept? Well, for a y-intercept, we're going to make x equal to 0. So when we do that, our x is going to equal 0. So we have 2 times 0 minus y equals 8, which means, let me pull that over here, we're going to have 0 minus y equals 8, which means we have negative y equals 8. Remember, this is really just a negative 1y, so that means y must equal negative 8 when we divide both sides by a negative 1. So our y-intercept, and hopefully you already have this, our y-intercept, I don't know what happened there. Our y-intercept is going to be 0 for x and negative 8 for y. And so now we're ready to graph this. So let me change to my color. Use my red for my x-intercept. So that's at 4, 0. So we go right 4, 1, 2, 3, 4, up 0. So right there. And then our y-intercept is going to be at 0, 8. Oh, way down here. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be way down here. Maybe extend this line out in green a little bit here. And then we can just go ahead and make a line. And we can see that our line is going to look something like that. And there's our equation using the intercepts and standard form. All right, now let's take a look at another form. The next form we can look at is, how about slope-intercept form? Slope-intercept form is a nice, kind of like I said, a nice way to kind of go in between. All right, well, slope-intercept form is kind of the most famous of the forms. So let's say for a second that you have a couple of points, okay? So let's say you have the points, let's say you have the points 2, 5, and you have the point 0, 5. And right now we're going to be working on slope-intercept form. And so let's say we want to write an equation in this form right here. Now, what we could do is, first of all, what information do you automatically know when you're looking at this problem? Well, yeah, you already know B. And because B, remember from our standard form that the y-intercept is always found by making x equal to 0. Remember that on those examples above? So if you see this, if you see an x equals 0, right away, that number with it is the y-intercept. And in slope-intercept form, like we've talked about earlier, y equals mx plus b, b is your y-intercept. So right away in this problem right here, we can say that we have y equals mx plus, in this case, 5. So we already know our y-intercept is 5. Okay? Now, that's easy. So now what we can do is we can go ahead and solve. We need to find the slope. Now, there's a couple things we could do here. For the slope, we could do a couple things here. We could temporarily plug a point in, and we could solve for m, or we could use the slope formula. Remember, we talked about that earlier. The slope formula is y2 minus y1 over x2 minus x1. So if we put these numbers in, and let's just say, okay, so this is the first x value I see. I'll call x1. This is y1. This is x2. This is y2. what you need to do is you just need to go ahead and, okay, well, what's y2? Well, y2 is, well, looks like it's 5 minus, what's y1? Well, y1 is 5 also. And then what's x2? Well, x2 is 0. And then what's x1 is 2, so 0 minus 2. So I get 5 minus 5, which is 0. And I get 0 minus 2, which is negative 2. Well, 0 divided by anything doesn't matter what you can take 0 and divide it all you want. By any number, you're still just going to get 0. So now you have an equation of y equals 0x plus 5. Or you can get y equals 5 because 0x is just 0x goes away to nothing. Now, could we have gotten this by plugging one of these points in and solving for m? I think we could have. So let's take a look at that. So let's say we plug in this point and the b that we know is 5, and let's see what we get. So instead of a y, we can temporarily replace it with a 5, this y value, equals, instead of an m, well, we don't know m. Instead of an x, we can temporarily replace that with a 2. And instead of b, we already knew that was 5, right? 5. So solving for m, we just subtract 5 from both sides. So we get 0, let's go over here, equals 2 times m, or m times 2, same thing. Divide both sides by 2. Look, you still get 0, so m equals 0. So yep, you get this. You can do the same thing either way. You could plug in an x and y value and use the slope form. You could use the slope formula, or you could plug in one of the x, y values and solve for m. Either one's fine. All right. So for this next example, I want you to go ahead and write the equation of the line. And let me give you this one here. So let's go with let's go with 0, 1. Write the equation of a line. It goes through 0, 1, and 4, negative 1. So right now, I want you to go ahead and pause the video. Pause that video. And I want you to go ahead and write that equation really quick. All right? All right. So what did you do first? Well, the first thing you probably can see right away is that I was nice to you and I gave you a y-intercept. So now we know that in y equals mx plus b, we know that 0, 1, this is our b, this is our y-intercept. So we have y equals, we have mx plus 1. Now, the next thing I'm going to do is I'm going to solve for m. And I think solving for m is probably the best thing to do is use the other point that you didn't get your y-intercept from and solve for m. So instead of a y, what can I do? Well, I can plug in a negative 1 equals m. I don't know m. I'm going to figure it out in a minute. X, what's the x value here? It's times 4 plus the y-intercept that I was already given. All right, so add. So let's see here. So I'm going to subtract 1 from both sides. So what's negative 1 minus 1? That's not 0, is it? No, that's negative 2. So negative 2 equals 4m. I just switched the 4 and the m around. Divide both sides by 4. Divide both sides by 4. And now what do I get? I get, let's see here. That's m equals negative 1/2. Okay? So there's your slope. Here's your y-intercept, and now you're ready to write your equation. So your equation is y equals negative 1/2 x plus 1. Now, I could have, if I wanted to, I could have had you graph it, okay? And I didn't say graph it, but if you did graph it, it would be pretty easy to graph this really quick. Let me go over here and move my graph over a little bit. Let's see here. So if we wanted to graph this, we could just simply quickly make a graph of this. And so something like this. Hopefully we can fit it on the size of a graph. And Get a line here. All right. Change the color a little bit here. So what's our y-intercept? Well, change the color here. I don't know how I did that. All right, so we'll have the x-axis in black and the y-axis in red. I don't know why that happened, but OneNote wanted it to be that way. All right, so we'll graph our points in green. How's that sound? All right, cool. So now the y-intercept is going to be 1, and then we can use our slope here to make more points, right? So our slope is -1/2. That means I can drop 1, and then I always run to the right if I can. So I drop 1. My rise is -1, so I drop 1 and I run 2. Drop 1, run 2. And so I'm getting a line that looks something like green, like this. And I'm done. Now, the last thing I want to talk about, and it's probably the one my guess is you've seen a lot of these, and this is a little bit of a review for you. But the last thing you probably haven't seen as much of, and I want to kind of show you the niceness of this, is it's called point slope. Okay, point slope. Now remember, in the beginning of this video, I said that point slope, the equation for point slope, is y minus y1 equals m times x minus x1. All right, so let's take a look at an example where we can do point slope. Now, let's say that we're given, we'll do a couple examples in point slope. So let's say that we're given, we want to write an equation in point slope form. And we're given that our slope is 2/3. So our slope is equal to 2/3. And our y, and then they're given a random point. Let's just say we know this random line is going to go through -6, 1. And we want to write it in point slope form. Okay? All right, so let's give it a try. Well, what do we have so far? Well, first of all, this, you got to kind of know what you have here. So this obviously is going to be your m. I'd like to change the color on that. This is actually going to be your m, your 2/3, because that's your slope. And then this is going to be your x1, y1. That's a given point. So your given point is going to be your x1, y1. And so now we can go ahead and plug that information into our point slope equation. All right, so we have y minus, well, what's y1? Well, y1 is 1 equals m. Well, what's m? Well, m is 2/3. And times, parentheses, x minus x1. Well, what is x1? x1 is -6. So you're going to have minus -6. I'll put that in parentheses just so we can see that. Now let's clean this up a little bit. So we have y minus 1 equals 2/3, parentheses, x, a minus and a negative is a positive. So it'd be x plus 6. And we're done. You're in point slope. Now, an interesting thing would be, hey, let's put this in slope-intercept form. Okay. Now that we have point slope, let's see if we can't convert this to slope-intercept. So this is point slope. So sometimes your teacher or whatever will say you're done. Once you get in point slope, you're done. Just write your equation in point slope. Sometimes they're going to want you to write it in slope-intercept. So how would we do that? Well, that's pretty simple. You just take this 2/3 and you would just distribute it through. So now you have y minus 1 equals 2/3 x plus 2/3 times 6. And I'll just put that 6/1. Okay, so now it just becomes a little fraction simplification problem. So we have x minus 1 equals 2/3 x. Now I like to simplify first. So let me change my color here a little bit. So I know that 3 goes into itself once and 3 goes into 6 2 times. Now I can multiply straight across, and I get 2 times 2 is 4. 1 times 1 is 1. I don't need to write it. Okay, so I'm almost done. Now remember what slope-intercept form is. It's y equals. So the last thing I need to do is I need to add a 1 to both sides. So my final equation is y equals 2/3 x plus 5. And I'm done. And this is your slope-intercept form. Slope-intercept form. Now, one thing I want to emphasize here is this equation right here, highlighter, this equation in point slope right here, right here. Don't worry about those arrows. It's the exact same thing, okay? These two things are the same. Just because I put one in point slope and one in slope intercept, I didn't change the value or anything. These two are the same thing. They're just different forms. It's the same thing. It's just like taking water. You can freeze water and get ice. You could melt water or H2O. You can heat it up and get steam, or you can just have a liquid. It's still water. It's just in different forms. And that's what this is. This is the point slope form, and this is the slope intercept form. It doesn't matter. Either one works. Some forms are better than others. Just like sometimes it's good to have ice, sometimes it's good to have water, sometimes it's good to have steam. It just depends on what you're looking for. Okay, so this next one is all you, ladies and gentlemen. So let's say that I give you a point, and it is -8, -5, and it is m equals -3/4. Okay, and so here's what I want you to do. Part A, I want you to write an equation in point slope form. Okay, point slope form. And then in part B, I want you to write it in slope intercept form. Okay, then I want you to write it in slope intercept form. And so let's go ahead and do that really quick and see what we get. All right, so pause the video. I want you to do it on your own. Okay, just cross your fingers, make sure you pause the video. I'll fix my hair a little bit. Looks like it's sticking up a little here in the picture. And that's better. And then, so we're going to go ahead and let you do it and see if you get it. Okay, so now we're paused. Hey, welcome back. Hope the pause was nice. Let's see how you did. Okay, so we're going to put it in point slope. So the first thing I do when I put anything point slope or slope intercept, I always write the equation. So for point slope, it's going to be y minus y1 equals x, equals m times x minus x1, right? Okay, so now let's just plug some information in. So again, this is our x1 and this is our y1. It's our given xy point, right? All right, so now let's go ahead and take us through this. So instead of a y1, what can we put in for y1? Well, yeah, that's a -5. So we get y minus -5 equals m. Well, what's our m? Well, yeah, that's -3/4. And then we have x minus x1. Well, what's x1? Minus -8. Now, we always want to simplify this as much as we possibly can. So let's go down a little bit. And so here we go. So when we have a minus and a negative, that becomes a plus. So we have y plus 5 equals -3/4 times, well, minus and a negative again is plus, so now it's just x plus 8. And this is PS, point slope. You're done, okay? All right, so now we have in point slope, let's go ahead and put it in slope intercept. That's part B. Well, how would we do that? Well, the first thing we want to do is just a simple distributive property. So we have y plus 5 equals -3/4 x plus -3/4 times 8. Just distributed this -3/4 across. All right, so now let's go ahead and do the math here. All right, get comfortable here so I can do my math. And let's see here. So a couple things you could do. You could reduce first or multiply first. I always like to reduce first. 4 goes into itself 1 time, and 4 goes into 8 2 times. So now I have y plus 5 equals -3/4 x, and then this is negative, right? So it's going to be minus -6 or -6. All right. And so now I need to solve for y. So I'm going to subtract 5 from both sides. So now I get y equals, because the 5's canceled out, -3/4 x. -6 minus 5 is -11. And there's my equation in slope-intercept form. And I'm done. All right. So let's do a grand finale problem, shall we? Here's the grand finale. Our grand finale problem is I'm going to give you 2 points, and our job is to write this equation in point slope, slope intercept, and also standard. Okay? So let's see if we can do this together. All right. So I'm going to have you try it on your own and see if you can do it. So here's the grand finale problem. Let's say you are given the points 2, 4, and you're also given the point 5, -2. And you want to go ahead and do 3 things. So first thing, let's start with point slope. Point slope. And then after that, let's do slope intercept form. And just for fun, let's also write it in what do you call it? Standard form. That'll be a lot of fun. Okay, so let's do it. Here we go. All right, so starting with point slope, part A. Well, point slope, again, is just y minus y1 equals m times x minus x1. Now, how is this problem different than what we've had in the past? Well, yeah, we don't have a slope, do we? So we need to go ahead and find the slope really quick. So if you can remember our slope formula, I'll write it over here, is m equals y2 minus y1 over x2 minus x1. Now, remember, it doesn't really matter which one's x1 and which y1, but I just go through and kind of just say, okay, this is the first x value I see, x1, y1, x2, y2. And now I just go through and put it into this formula, okay? So what is y2? Well, yeah, that's the -2. So we have -2 minus what is y1? That's just 4 over, this is m equals, over, let's see here, x2. Well, what is x2? x2 is 5 minus what is x1? x1 is 2. So now I go ahead and I do the math here. Well, what's -2 minus 4? That's -6 over what's 5 minus 2? That's 3. So m equals -6 divided by 3. So it's -2. I hope I did my math right. If I made a mistake, I don't think I did, but hopefully that looks good to you. I got all my negatives and copied everything down right. Okay. All right. If I ever make a mistake in these videos, just tell me on the next day, and then I'll feel bad about myself. Okay, cool. All right. So now let's go ahead and so now we have our m. Now we can use point slope. Okay. So point slope is this formula here. So instead of a y minus y1, and you could use either one of these points. It doesn't matter. But since I have x1, y1 on the first ones, I'll just use this for my point slope. It's the same thing if you use the other numbers, though. Okay. So y1 is going to be 4. So y minus 4 equals slope. Well, we now know our slope is -2 times x minus x1, right? So that's going to be, so our negative is x minus 2, right? All right, cool. And so this is our point slope. We should be done. There's no simplifying. There's no double negatives in here or anything like that. So boom, point slope, we're done. Now, let me change the color. Now let's do slope intercept. Well, slope intercept is going to be, so we'll start out, we have y minus 4. Now let's distribute this -2 through. So -2, we're on part B, by the way. negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And then we'll add 4 to both sides to get our answer in slope-intercept form. So now we have y equals negative 2x plus 8. And that's our equation in slope-intercept form. Now, the last thing we want to do is we want to put it in standard form, okay? Well, standard form is really easy. Standard form just says, okay, move the x over so it's not, so the x's and y's are together, and then the constant, the number without the variables on the other side. So part C, I have y equals negative 2x plus 8. And then I just want you to add 2 x's to both sides. So now we get y plus 2x equals 8. And now here's the thing with standard form. You always want the x to come before the y. So we need to switch this around and say this is 2x plus y equals 8. And there is our equation in standard form. So what do we have here? Let me just make sure. We have point slope right here. We have slope intercept, and we have standard. Again, all three of these are these three answers. They have this, do that. They have the same value, okay? All three of these have the same value. All right, so here's what I want you to do. I'm going to give you 2 problems right now. I want you to work these problems out, and I want you to email them to me at gregory.roden at d11.org. And I want you to email me your work just like I did that, so I know you watched it and you can do this. So here are your problems. So I want you to email me the answers. You don't have to email me all these notes you just took. Just email me these. Email work to, what is it, gregory.roden at d11.org. Okay, so do it on a piece of paper, take a picture, do a screenshot, whatever it takes. You guys are figuring this out so far. Okay, so here's what I want you to do. Number 1, I want you to do, I want you to write in, let's do point slope. Write in point slope. And it's going to be, I'm going to tell you, I give you the points. M equals negative 2/3, and the point is 3, 0. Okay? And then after this, number 2, I'm going to give you the point 4, 1 and 8, 2. On this one, I want you to do 2 things. I want you part A, I want point slope, PS for point slope. And then part B, I want it in slope intercept. And the last thing I want you to do is, on these 3 problems, I want you to email them to me. If you don't have graph paper, you can just kind of make a nice graph on regular paper. But I'm going to give you I want you to take this equation. Let's go 4x plus 2y equals negative 8. And I want you to, so we're in standard form, right? So what I want you to do, I want you to graph this using the intercepts. Graph using x and y intercepts. Okay, so get those to me, graph them using the x and y intercepts. So I want to actually see a graph. So 3 problems, email me your work, and I will give you credit for those. If you have any questions, we'll definitely talk the next class, okay? Hey, thanks for being here, guys. Hope you're having a great day. Happy Monday to you, and we'll see you next class. See you later. Bye.